Today is particularly interesting because, in fact, we have Travis here with us, and I'll let Travis chime in just a sec. But Travis had shown me this project that he and the team are working on called DataPM, which is very cool. I won't steal the thunder too much. I'll let Travis sort of describe what DataPM is, but he described it to me as sort of a package manager for pre-built or existing data sets, some of which are in real time. And one of those data sets that we're gonna kind of play around with today is a stream of transactions coming from Coinbase on crypto trades and things like that. I'm not a big crypto person myself, but I thought it was an interesting example of processing financial transactions, time-based financial transactions, and a great use case that people can sort of like understand and immediately see how that could work. So today, what we're going to do is I'm going to show using DataPM to source this Coinbase data, pumping it into Decodable via our REST APIs, which DataPM has a pre-built connector for, and building a pipeline to sort of cleanse and sort of change some data types and those kinds of things on the data, and then do some real-time windowed aggregations to basically compute what you would see on most finance websites on market data, things like volume and average trade price, min and max and those kinds of things, including change calculations. So we'll do some fun windowed lag functions so that you can see exactly how you can build deltas on data as it sort of changes. Before I sort of get into that, Travis, maybe you could tell us a little bit more about DataPM and what you guys built, because I think it's really, really cool.
Yeah, thanks, Eric. Really appreciate it. I'm excited to see what you do with the data that's streaming through, what you were just describing. So DataPM stands for Data Package Manager. The idea is, if you've ever been a developer and package managers, NPM, pip, Maven, others, they're these pre-built great resources for code that you can use, dependencies that you can use in your own projects. Why don't we have that for data? Where does that exist exist in the world for data? And so DataPM is intended to be an open repository of publicly available data that you can just go search and discover what's out there. So one example you might search for is cryptocurrency ticker streams. If you're into the cryptocurrency realm, these are useful for discovering the current price and I guess tracking the historical price. So what Eric has up on his screen here is datapm.io, and this is one of our packages. You'll see Eric's going to probably demo the using of the DataPM client. So we have this registry client here that's like a catalog of the data that's available, and then right over there on the right-hand side is your DataPM fetch command, which that client basically lets you instantly grab that data no matter where it lives and put it where you want it. And so in this demo, it's going to be decodable. I think you're muted.
I am forever muted. Okay, I'm officially unmuted. Yeah, so this is super cool. So we're actually going to work with this data set today, and I'm going to show you running the DataPM command and then pumping that into Decodable. So just to give you an idea, what I'm actually going to do is just copy this DataPM fetch command and run it here. And so basically, DataPM is smart enough to figure out what this data set is. It figures out the schema, and then it asks me to select a connector. I'm going to select Decodable, but you can see some of the other connectors that DataPM supports. We like Decodable best, but we understand that these other things exist. It has full integration. So I'm actually going to use this eSummer test1 account that I have created with Decodable, and it's going to ask me how I want to authenticate. And what it's doing under the hood is using Decodable's APIs to be able to communicate. So REST APIs. So Travis and team have done basically what you can do with our REST APIs, sort of direct integration. And so it's going to handle, and this I think is the coolest thing in the world. So it handles the creation of the decodable connector, connection, and the stream that's going to hold all of these transactions. So it has a default stream name and a default connection name. I'm going to let it just do that. In this instance, it found that these already existed because I ran through this earlier today. And in fact, it double checks that the connection is up and running and sort of ready to receive data. And then it sort of asks me how I want to handle, cases where, the schema might not be as expected. And then connects to Coinbase via WebSocket and just starts pumping data into Decodable. So I'm going to flip over to Decodable, where I have a pipeline that I created. Well, before we jump to that, so here's the connection that DataPM created, and you can see, its description is created by DataPM. It has the schema that matches the data set, according to the registry information that DataPM has. And this is the REST endpoint that DataPM is posting to in JSON format. And then this connection is attached to this stream that was also created by DataPM. So the schema here matches the connection, and it's receiving everything from that REST endpoint. You can see that there's no event time field specified because we don't yet have the timestamp, which is, where's the timestamp? Yeah, so the time is currently a string. One of the things that we're going to do in our pipeline is we're going to turn this into a timestamp so that we can do windowing and time-based operations on it as well. And you see some of the other fields are doubles. We're going to convert those to decimals, and maintain precision and those kinds of things while we operate on the information. Most of the other fields we're going to sort of leave as they are. And I didn't have to do anything. DataPM created that stream and that connection for me, which is super cool. But there is this pipeline. And so this is, I just called this Coinbase transaction cleanse. And so it's reading from this source stream, and it's going to insert into a Coinbase exchange transactions stream that I created. And you can see here, it's just really, really simple data type conversion, some field renaming, turning type, which is a reserved SQL keyword, into TX type, just so that it's a little bit easier. I don't have to quote it in my downstream queries. And the same thing for time. So here I'm parsing it from the RFC 3339 format, I believe it is, into a TX time column, so that the timestamp is sort of pre-extracted for me. And you can see that I've converted, what were doubles into decimal format with some guaranteed precision. I can run a preview on this, and I'm going to make sure this is still streaming records. So this will fire up. And for those of you who have seen or played with Decodable before, you probably know this functionality. This will attach to the stream. It'll run this query, and it's going to show me a sample of that data. So you can see that my timestamp's extracted. You can see that I have all the fields that are advertised by that are registered in DataPM. So I have ETH to USD purchases and Bitcoin USD purchases. And you see all the different fields like the open, volume, low and high prices, different bids, and whether these are buy side or sell side transactions, right? So somebody buying cryptocurrency or selling cryptocurrency. And we're actually going to play around with that and do some filtering. and then some internal stuff like trade IDs. And so this is outputting to this, what I would call sort of like a cleansed or pristine stream. We can see what that looks like. And here you see, the sort of final data types. I've converted certain things to big ints, to make sure we don't overflow things. I've turned some things into decimals. And probably most importantly, in Decodable, once we have a timestamp column, we can tell Decodable that this is going to be the column that it should use to understand event time, which will allow us to process data, with respect to event time, rather than the current wall clock time, what we would call processing time. I could add lots of other fields and stuff like that, but you get the idea. And so now this pipeline is up and running. We can see, it's currently, in its running state. It has, records per second, and then sort of total data volumes that are sort of moving through the pipeline. And we saw a sample of what that data looked like. So now what we're going to do is do some, reasonably interesting, kind of a little bit fancier windowing on this. So I'm going to create a new pipeline, and I'm going to pick the cleansed version, our pristine version. So that as my input stream. For my output stream, I don't have one created for now, so I'm going to skip this for now. Decodable has support for creating an output stream that matches your pipeline. It's a relatively new feature, sort of nice quality of life feature that we added pretty recently. And what I'm going to do is I'm actually going to show you a progressively, more and more interesting pipeline. As soon as I get copy paste to do what I expect it to do. So I'll spare you the overhead of watching me type this. So this first query is going to do the windowing. And this is probably, the most interesting portion of, one of the interesting things that we're going to do today. So reading this query from sort of the inside out, we're going to take this Coinbase exchange transaction stream, and we're going to create a tumbling window, which is a window that sort of moves in fixed increments in time. In this case, 5-second intervals. So we're basically going to chunk the stream into these 5-second intervals based on the transaction time column, which is the one that we extracted. We're then going to filter that data down to just the Bitcoin transactions and just the buy side. So we're going to ignore the sell side for now. And then we're going to group by the window start time, the window end time, the window trigger time, product ID, and side. So just to provide a little bit more color on this, remember that side here is now always going to be buy. Product ID is going to always be Bitcoin USD, but we want to group by those just so that we can create some aggregates. These columns, these window columns, are actually special. So when you create a window in Decodable, the system automatically creates these 3 columns for you. Window start time is going to be the time of the window start. So every 5 seconds, this is going to tick up, and the window end time is going to be the start time plus 5 seconds. And so that'll be sort of the range of data that we're looking at. The window time is this special internal column that is the trigger time of the window. And we're not actually going to use this in this query. We're just going to push it through into the output so that we have it for a future query. And I'll talk about why that is in a second. So we're basically just going to count the number of trades, and we're going to call that volume. We're going to take the minimum price and call that price min. We're going to take the maximum price and call that price max. We're going to take the average price and call that price average. And I can run a preview of this. And Coinbase sometimes cuts off data fetching, which is why I keep checking on this. DataPM will properly exit if Coinbase kind of shuts off the stream. So what this is going to do is create one record every 5 seconds. And there's going to be a little bit of a delay before we start receiving data because it sort of has to wait for that 5-second boundary. So you can see that it's starting to output some data. I'm going to format this so it's a little bit easier to read. And you can see our window time is, and this is all, based on event time. So, 6:17 p.m. and 55 seconds. The window end time is 6:18 and 0 seconds. So basically exactly 5 seconds worth of data. And you can see that the window time triggered right at the end of that window, which is exactly what should happen. So at the end of the window, it snaps, it performs the aggregates that we talked about. You see the buy side, you see that there were 8 transactions within that 5-second window. And we see the min, max, and average price that happened within that 5-second period. So we can see, our low, we can see our high, so on and so forth. And you can see that, the next 5 seconds, there were 33 trades, then there were 40 trades, then there were 11 trades, so on and so forth. And so you can see all these prices that change, over time. So pretty cool. We've effectively created basic descriptive, stats off of this. So now I'm pasting in, this query contains the query we just saw. So it starts with the data the output of this query. And then it selects all of these columns and it performs what are called analytic window functions or over operations. And so these are a little bit weird to think about if you've never seen this before in SQL, but it's really common for these kinds of analytical operations. So here's the right way to read this. Lag is an aggregate function. So if you imagine each record of these of this data as a record within the stream of output, the lag function looks backwards at the previous one record. So we're basically looking at, for each record, we're looking at the previous record. And so for the first record, there isn't going to be a previous record. So this is actually going to be null for the first record. But then every record after that, you'll basically have not just the current values, but the previous value as well. And we're going to look at that lag over the data that is coming out ordered by window time, because we're relying on order by looking backwards at one event. So we need to make sure that that data is ordered the right way. And internally in Decodable, that requires this to be a time column. And so that's why we're using the window time field here. And window time, it's not sufficient for it to just be a timestamp column. It has to have this special time attribute thing, which is a little bit tricky. I'm gonna hand wave around that. Go with me on that. I'm happy to answer questions on what that is and what that means. So we order by time. We take the previous record and then we name it the price, minimum, previous. So the previous value. And we do this for each of the min, max, and average. And so now we have the current values and we have the previous values on each record. Whoops. And I have an extra comma, which Decodable is going to yell at me about. Not allowed to have an extra comma. And I'm going to start a preview. I'm going to make sure that we're still generating data. We are still generating data. So what we should see now is the same output that we saw before, but we should have 3 additional columns that tell us the previous value. And you can imagine what we're going to do with this data in the next query. But first, we're going to make sure that this looks right. So in just a second, remember that this is a 5-second windowed function, so that's why it's going to take us a little bit of time. So again, we have all the same data that we had last time, plus we have nulls for our first record, which is expected. And then here you can see in the second record, let's just double check that this is right. So 4366457, 4366457. So all 3 of these min, max, average are the same. There's only 2 records. This one has 23 records. And you can see that there's a little bit more spread here. And as we go again, so 43, 662, 16 for the minimum previous value. And the minimum value is 16. So these are right. So now we have both the current value and what the value was 5 seconds ago. And you can see that we continue to get that for all of the records in our window. And so now that we know the current value and we know the previous value, now we can do something even more fun, which is going to be our final query. And by the way, this process of sort of incrementally wrapping these kinds of queries and enriching them further and further is one way I like to build queries, because I know what each step of the query is doing. And again, I have that comma mistake. We're going to fix that. So again, same thing. We have this inner query that we just showed you the output, and now we're wrapping it again. We're taking all of the same columns that came out. So we're going to get all of what we just saw, but we're going to add basically a min change and a max change. And in fact, let's add the average that we have. So we have that as well. And so basically, we're just going to take the current value minus the previous value, and we are going to run that. And so basically, if the price goes up, we'll get a positive number. If the price goes down, we're going to get a negative number. We're still generating data, so that's good. And here you can see I've added the insert into Coinbase transaction summary. And that's because this is sort of my final bit of processing. And this is the result that I want to turn into a stream so that maybe I can write it to S3, or I can send it to a Kafka topic or Kinesis topic or any of the supported connectors that we have inside of Decodable. And so now we have all the same fields, and you see we have nulls. And for the change, we also have null, because anything minus a null is a null. So it's probably more interesting to look at the second record. In the second record, you can see that we have the current values, we have the previous values, and now we also have the change. So there were 29 transactions. You can see that the minimum price jumped up by $3.73. The max price jumped up by $2.67, and the average price jumped up by $2.46. And so now we can see, the minimum is increasing, the max is increasing pretty significantly, and the average is also increasing. But here, the max price has actually declined a little bit, but the min price is still rising. And you see the average and so on and so forth. So this is really cool, because we actually now have for every 5 seconds, and we could easily change this to every 1 second or even every 1 hour, depending on what we wanted. We can create these quick roll-ups without writing any kind of specialized code and produce it. I'm actually going to keep this. Let's do 1 second. So we'll do 1 second rollups, and we're going to create this summary, and I'm going to call it summary 1 second, just so that we know what that looks like. And I can go ahead and auto create the output. I'm going to name this Coinbase TX 1 second aggregate. And we're going to go ahead and create it. And so now I have this pre-built pipeline with a query that we know works. And this should have created an output stream, which it did. And you can see it automatically inferred all of the different data types based on the query that we were running. It picked up the window information. And in fact, we're going to make the Windows start event, and we're going to tolerate, I don't know, let's tolerate 1 second of late arriving data. We'll save this. And so now I can create even further aggregates on this data if I want based on time. And otherwise, like, you see all the details, and we really didn't have to do very much other than know how to write our query. So now if we want to, we can start this query, and in Decodable, you can specify the number of tasks. So this is basically the parallelism of the query, how many workers there are. And the force flag, we don't need it, but if you want to basically discard any information about the last place you left off when you last ran your pipeline and have it sort of jump to the most recent data, you can optionally turn on this force option. We're not going to do any of that. We're just going to start our pipeline. And so this pipeline will actually take a second because it's going to allocate some resources that are dedicated to this pipeline behind the scenes. And it's going to wait to see that it's getting healthy metrics back out of the pipeline. So this actually will start processing data before it actually tells us back to the UI. And that's because we monitor it for a little while to make sure that that pipeline is stable and healthy before we tell you that the pipeline is up and running. Excuse me, otherwise this is just a standard pipeline, and it's going to work exactly the same as our cleansing pipeline. You can see here we have 15 records going in, 14 records going in per second, 14 records coming out because we're just transforming that data. But for our aggregation pipeline, what you'll wind up seeing is we'll wind up having more input records than output records because we are aggregating that data over those windows. And so Decodable is smart enough to tell you, what those metrics are, because we fully instrument the underlying pipeline for you. And again, just to sort of show you what we could do if we wanted to, if we wanted to output this data to Kafka or Kinesis or Redpanda or S3 or whatever your kind of weapon of choice is, we could easily go ahead and create this, just for maybe I can't sort of make this up on the fly because I need an ARN, but maybe that's a better example. Maybe I take Redpanda. So here, if we had sort of a broker, for instance, and like maybe we had like Coinbase transactions, and we could sort of decide how we want to authenticate and how we want to output data into that topic. It's going to ask me like, where do we want to get this data from? And we could select either our aggregates or our raw data. We could even create a new stream if we wanted to. We could also just capture the raw data. So, for instance, if I set this pipeline up, anybody else in the organization who has access could potentially build downstream analytics and processes off of any of these streams that that we allow them to do. So if they want the aggregate data, they can do that. If they want transaction data, they could do that. And we're gonna like figure out what the schema looks like depending on which they select, which stream they select. We can go back to our pipeline. We can see that it's now running. We have 15 records per second coming in, 1,000 records in total since it fired up. And you can see it's outputting less than one record per second, or maybe on average one record per second. That's exactly what we expect it to do, because remember, we're doing 1 second aggregates. And sometimes, it's just ahead, sometimes it's just behind, but it's typically very, very close. And if we wanted to, we could, run a preview of this pipeline again, just to sort of double check that what the data looks like. But we've already done that, so we have a pretty good idea what this is going to look like. So that's it. So with that, we, in 30 minutes, 20 minutes, we sourced a bunch of financial transaction data We got it into Decodable. We transformed that data and sort of cleaned it up a little bit in terms of its data types. And then we created some aggregates for that information, you know, to be able to understand things like market fluctuation. In this case, the buy side of crypto purchases. Super cool. And you can probably see that all of this would work for, you know, typical, you know, financial transactions. There's all sorts of different kinds of functions that we could have used to otherwise aggregate or you know, or transform this data. But this just gives you some idea what this looks like. And now this pipeline is up and running. And if I go here and I actually stop DataPM from ingesting data, what we should see in just a second is that the input records will start to fall. And that's because this counter is actually a moving average. So at some point, you know, it'll sort of whittle its way down to 0 as it gets there. I don't remember exactly the frequency that it updates, but you get some idea about whether or not, you know, your data is actually flowing through the pipeline. And that includes the upstream cleansing pipeline, which we should also see this, you know, starting to tick down, which makes sense. There's no more data coming in. So you see total records isn't updating anymore, but records per second is sort of gently falling over time. This is incredibly useful to actually understand whether or not data is flowing through the system, you know, and what it's, you know, whether or not your pipelines are healthy. With that, I'll pause. Do folks have questions? What can I tell you?
We have a question in the chat from Benjamin, who I know is battle-hardened in window aggregations. So we don't mind taking a look at that and answering.
Yeah, let me just pull that up.
I can read it if that's easier, or Benjamin can ask.
So windowed aggregations, is Decodable automatically picking the required memory to perform the analysis, or do you need the user to tune the pipeline according to the ingest load? What a great question. We are making some assessments about the memory required for this. And part of the reason why we're able to do this rather safely is because we know the aggregate functions and how much state they actually maintain. So min, max, average, for instance, all maintain minimal state. So there's no risk for us to blow out the memory footprint in the underlying pipeline. You know, God forbid, if something horrible did happen and the pipeline gets blown out, that's part of the reason why we isolate each pipeline with dedicated resources. So the trade-off there is that they take a little bit longer to get going. Like when you click start, that's why you see it take a couple of seconds to kick in. The upside is that you're not going to disrupt any other pipelines that are running on the system. So you can't accidentally take down a neighboring pipeline because you run out of RAM or lose connectivity to something like a network partition or something like that. I have to think about this, but I think all of our aggregate functions are relatively capped in terms of the memory and state that they use. Behind the scenes, what we're doing is the aggregate function is using an underlying state store that and deciding how much memory to page in or page out, you know, of that state. That state storage for us is RocksDB under the hood. You know, we're not sort of shy about sort of like how that works. So the aggregate function is, you know, potentially it could perform worse, but it's never going to blow out, you know, the memory allocation. If it did, we would see the pipeline fail. Like if something went horribly, horribly wrong, we would see the pipeline fail, and a memory allocation issue like that is actually a system problem. And so what Decodable would do is simply restart that pipeline. It might continually run into that error. And so eventually what we'll do is we'll surface an error back to the user in the off chance that, like, you know, one of our aggregate functions did something, you know, really, really weird. Do aggregation functions work across task nodes, or is there some consideration the SQL author needs to take into account? Again, what a great question. So aggregate functions operate on the group by clause. So what's happening under the hood is when you say group by Windows start and product ID side, what the stream processing engine in Decodable is doing is it's actually creating what's internally called a partition, not to be confused with Kafka partitions, but a data partition for the combination, for every combination of those values. And then each combination is assigned to a worker task. And so in our case, we only have one task. So it's always going to be assigned to that same task. But if you, again, like it'll never run out. Well, that's not true. There's corner cases where it could actually sort of like blow out the memory. But in practical terms, what will happen is it'll do some paging work to try and balance the memory footprint on that. So it will slow down if you have effectively high cardinality. So if the combination of these values is measured in like billions or something like that, but they're all going to one worker, then you can actually see some pretty significant slowdown in those cases. And that's why some pipelines will run faster than others. The way you battle that, of course, is if you want your pipeline to go faster, when you start it, you just give us more tasks, which is the unit of billing, right? Because we're doing sort of more processing on your behalf there. So you can basically tell us, I want 10 tasks. And under the hood, what we'll do is we will take all of these different partitions and assign them to different workers so that you can perform those aggregations in parallel. But to specifically answer your question, no, you don't aggregate over tasks. The aggregation happens within the data partition, which is always sent to a single node. And that has to be true because there is no other way for at least some aggregate functions to be able to, they sort of have to see all the data, like unique or median or those kinds of things. Technically speaking, we would say those functions are not commutative and associative. And because of that, you can't aggregate the aggregates and still get the right answer, because order can matter, or the number of iterations of that can matter. Min and max, for instance, are commutative and associative. So you can do min of min of min of min. Same is true of max. The engine, I think it's still not smart enough to be able to know that kind of information about an aggregate function. So it will still want to do min for a data partition on a single node. Sorry, that's a really long answer. It's complicated. Is it possible to process or reprocess historical data? Good questions today. So today in the system, we do not give you the ability to specify the start position. So when you start a pipeline, we start from either the most recent event in the stream or the last place. If the stream had previously, or the pipeline had previously run, we always resume from the last checkpoint so that we process every event exactly once. And there's more detail there that I'm skipping over, but for now, let's just pretend that it is that simple. We are going to be adding the ability to specify an arbitrary position in the stream to allow you to kind of go back way, as far back as you want in the stream, assuming you have the retention time in that stream. If you want to process data that's kind of already at rest, for instance, in something like S3, you will see us build connectors that will pump that historical data back through the pipeline, like an S3 source that sort of scans the data and sort of figures out which files to process, for instance. Excuse me. If you're reading data from Kafka, you'll be able to coerce our connectors into going as far back, or I say Kafka, I mean Kinesis, Pulsar, any of those kinds of systems, GCP PubSub. You'll be able to sort of go back in time and process those as well as our internal streams, but we haven't revealed that functionality to people just yet. Great question though. I'm curious, is that an interesting functionality to you, Robert?
Yes, always, right? Always have to have the ability to go back, right? And have to reprocess things if there's some issue or bug in a pipeline or
right. Yeah, that makes also a lot of sense.
Or if you want to train a model with some historical data, also that's a good use case, and I'm glad to hear that it's on the roadmap.
Yeah.
A lot of the data. Go ahead.
No, sorry. Go ahead.
I had another question.
Shoot.
Regarding support for schema registry.
Mm.
You mentioned like
Yes.
Aggro and Protobuf and maybe JSON schema.
Yeah, great question. So today we have some support for, let me just see if it, sorry. I think if we select Aggro, Josh, you're on the line, right? Where does, is it not in the UI? Where does it kick in?
It might not be in the UI yet. I know they're hard to work on it. If we switch to the CLI, there's totally support for it. So you can specify your schema registry URL, you can specify credentials, and that will let you effectively use the schema registry. Some of the stuff on the roadmap is now to like inherit the schema from the schema registry and apply it to the connection. And I think the UI work is sort of part of that.
Yeah, and we have it in our docs. I think it's, Josh, correct me if I'm wrong, but I think it's a set of properties that allow you to specify the schema registry URL.
Yeah, that's exactly right. I don't have the docs open, but yeah, you just specify your properties, same as you said, a topic and a broker. You specify the schema registry URL, and then if there's credentials to access it, you do that there.
And the supported schema types include Avro and Protobuf and JSON schema, the same as the types that schema registry supports, or?
Sorry, Josh. No, you go ahead.
Yeah, so today, and again, this is outside of the work that is literally ongoing as we speak. Today, it's the Avro schema registries, the supported one, or at least the Kafka connectors. But that said, that's actively changing like as we speak. So I don't want to promise anything, but I'm pretty sure they're looking really hard at Protobuf and JSON schema.
Great, thank you.
Yeah, you will see in the next, we have some really, really cool work happening here on sort of the developer experience and sort of quality of life. So you'll see some features and functionality to make it really easy to connect to that schema registry and automatically import, things from those supported formats. Yeah. Any other questions?
I was going to ask Travis, what's next for DataPM?
Sure, yeah. take a little time here. Yeah, so my goal for DataPM is for it to have tons of high quality available packages, just like the Coinbase one you saw. We just added, for example, 5 other exchanges, FTX, Kraken, and a few others. We're using this cryptocurrency as sort of a public demo. Hey, you know, this is freely available data. 5 years from now, I would love for it to be sort of like a GitHub for data, so that anybody can go create a package, put it up there, find something interesting, and create a community around it. You'll notice when you go to DataPM, it has GitHub-like issues, so you can go and see a package, track an issue, etc. And then we're also working with some data providers today that sell data to host their own DataPM registries, so that they can go and use this as a commercial out kind of pipeline out. And I'd like to see a buy button on DataPM. So if you have a set of data that you want to sell, you can sell it right there. Really love what you're doing here with DataPM and Decodable. That was a really cool demo. I've never seen that before, so I was super excited. I gotta say, I had tons of ideas.
Yeah, no, we love it. I mean, certainly in our position, we're always hungry for finding like really cool use cases that show off different bits of functionality, and having these like high quality data sets that are like ready to go is like a dream come true. Like, absolutely love it. It's just so much fun to play with.
Cool. All right, mission accomplished.
Anybody else have any other kinds of questions about Decodable, about DataPM, about Coinbase transaction processing? I've learned some really interesting stuff. The short answer is it's incredibly volatile. I'm not a crypto person, but it's incredibly volatile to watch those numbers come out. Or any questions about stream processing, Kafka, Flink, you know, any of that kind of stuff in general? We're always happy to answer those kinds of questions too.
Yeah, maybe one question. It's a little bit, out of curiosity. Do you have any kind of benchmark that you will be able to disclose about? If I think about your demo, will you have some benchmark to provide on what will be the required time to process those window-based aggregation from the input events to the output, let's say, like
right.
Do you have any metrics to provide that would be?
We don't have any that we expose, like as part of the operational metrics that we've shown there. In general, end-to-end latency for non-aggregation pipelines, which is the easiest thing to measure because the data is not like artificially delayed by like a window function, is sub 20, 30 milliseconds. Sometimes it's as fast as 10 milliseconds or even faster. But we don't commit to that. I think it also depends on whether or not somebody like which tier of Decodable they're on. So like the free tier, for instance, is it's a multi-tenant environment, and while each pipeline is isolated, it is on shared infrastructure. For some of our enterprise class customers, we do offer things like isolated tenancy and those kinds of things, which can make sure that you're only competing with yourself, where we can offer sort of better guarantees around what that latency looks like. For aggregated data, the latency is always at least the window function, is at least the window time. So there, it's a little bit harder to think about what latency really means, because you're sort of artificially delaying, the data for the completion of the aggregate function. I know you know all this stuff already, but I'm just sort of saying it out loud. Otherwise, on things like event throughput and those kinds of things, we haven't released like a formal benchmark of any kind. Anecdotally, we're using Apache Flink under the hood. And so we, we sort of we fix some bugs and, make some changes and stuff like that to it to suit our purposes. But we know that Flink handles some of the largest scale for, some of the public users like Lyft and Uber and Netflix and those kinds of companies that have talked about, their Flink usage. And it is not uncommon to see, definitely 5 digits, sometimes 6, hundreds of thousands of events per second per task, depending on the complexity of the processing that's happening there. But it's on our list to sort of put out like a formal benchmark about like what people should be able to expect for different tiers of Decodable. Sorry, that's a long answer. Does that make sense?
Sorry, I was trying to find the unmute button. So yes, that makes total sense. Thank you.
Yeah, so I mean, transparently, I don't know that anybody would use Decodable or systems like Flink and those kinds of things for high frequency trading, right? Because that's like a very specialized use case where people count like microseconds. That said, I think for most people and for most businesses, things like making product recommendation decisions or even like dynamic pricing systems, billing infrastructure. In fact, we use Decodable at Decodable for billing. Billing calculation. For those kinds of things, a couple milliseconds plus or minus is typically fine, but it's definitely faster than like the micro batching systems out there like Spark streaming and stuff like
that. Yeah, I was just trying to compare to just what you say, basically Spark streaming. And I was not thinking that it would beat an FPGA, but no, that's great to hear. Yeah.
Yes, we definitely aren't beating FPGAs, that's for sure. Very, very cool questions. Any other things top of mind? Or any product feedback? Anybody think we're doing it wrong? We should be building something differently. We're happy to take that feedback as well. Okay. Well, I don't want to keep anybody for the sake of keeping you, but I really appreciate everybody joining and for taking the time. If you have questions that maybe you didn't want to ask publicly, you want to talk to somebody here at Decodable, we're always happy to take your phone calls. You can ping me directly on our community Slack, or you can email info@decodable.co or sales@decodable.co, whatever is sort of most appropriate. And I think Travis is also on our community Slack as well. I think if you have questions about DataPM, I bet you Travis would be happy to hear that feedback as well.
Yeah, absolutely. Be happy to do that. We also happen to have a community Slack. Ours is a little less busy, but over there on datapm.io, you find ours as well.
Yeah, join that as well. Absolutely. With that, I'll thank all of you for hanging out with us on Thursday. It's always a pleasure to hear some of the questions, get the chance to talk to everybody. I hope to get the chance to talk to you offline as well. So let us know if we can help in any way. Please check out the Decodable and DataPM. You can get up and running with both of them right away. Otherwise, thank you all and have a great rest of your week.
Thank you.